Okay, the time is ticking away. Let's start. My name is Pawel Deska, and I'm responsible for the technical department in Klimaterm. And today, I try to show you how the R-290 refrigerant in heat pump is really important in our wave of the renovation in European Union. At the start, I can show you where we are and what we can do now. Before the aggression of Russia on the Ukraine, our target plan for the cutting, reduction of the household greenhouse gas emission was minus 44. But after aggression, we have to achieve minus 55. How can we do this? When we are looking for the whole, our surroundings, we know that we should go to the building site and to reduce almost 60% of the greenhouse gas emission. And we have to do this with the final energy consumption dropping down almost 13% and almost 80% exactly by cooling and heating. And at the end, we want to be in 2050 with strategy 0% of the emission. And what we need now? We need of deep renovation. What exactly mean deep renovation? Deep renovation, it's not only the changing of the heating source, but we have to do 3 steps. The reduction of the demand of the usable energy and final energy, and at the end, the primary energy. What does it mean, usable energy? It means that we have to look at our house and have to do some changing in this house structure. And it means that maybe we can use the new wall insulation, maybe we have to change the windows, maybe change the doors, maybe do some, how to say, do some changing in the structure. And this is usable energy. The final energy, and this is the point when I want to talk today, is that we can make the replacement of the heating source. And I mean replace from the fossil fuel boilers, coal boilers, gas boilers, to the heat pump. And I'm pretty sure that heat pump, especially with the refrigerant R-290, is the best solution in that case. But after the replacement of heat source, we can also replace also the ventilation inside. For example, from the gravitation to the heat recovery ventilation, it means recuperator, for example. And also, we have to spend some money for the regulation of the whole system. I mean, the proper regulation of the for example, floor heating and radiator. Yeah? We have to do the proper regulation hydronic system. Yeah? And also, we spend some money for the insulation of the piping. This is the final energy. And after then, we have also the primary energy. It means that we can get some energy by ourselves. It means the photovoltaic system and also the energy storage system. And we have all of these features, all of these units we have in our portfolio now. This is very interesting. This graph is according industry agreement for the energy efficiency in Poland. This is a POBI. POBI is an association which collect together all the not-profit institutions in Poland. For example, Polish organization to develop of the heating sources, heat pumps. And as you can see, this is a comparison between the heat pump and the comparison with the fossil fuel boilers and also the energy from the electric boiler. And this comparison was prepared especially for the building which have 150 square meters, according to Polish standard, which was provided in 2017. It means that for the 1 square meter per year, we have to use to achieve the right temperature for the whole season, 80 kilowatt hour per 1 square meter per year. When you multiply per squares 150, it means that we have to spend almost 20,000 kilowatt hours per year for this building for heating. And as you can see, heat pump now, especially heat pump with ground source and heat pump with the higher efficiency, I mean about COP coefficient, is almost 4 or 5 times less in spending money for the yearly heating. And I want to say something about this deep renovation and what we can achieve after that. Of course, we have deep renovation. It means that we change the windows, change the insulation, but nobody changed the piping. Almost no client decides to have new piping inside. And what we can do, if we dropping down with demands of the energy in our house, we can use this small piping and this radiator with the small area of the heat exchange, even without changing of the system. Yeah? And also, we can use the lowest temperature, because in standard fossil fuel boilers, for example, gas condensing boilers, between 70 till 50 degrees of the Celsius. The delta T, the difference between supply and exhaust is 20 kelvins. Yeah? But when we use the heat pump, we have the smallest delta T. It is 5 kelvins till 8. Yeah? But when we properly make this deep renovation, we can use the heat pump. But from my point of view, we have to use the right heat pump, not standard one, not with standard compressor R-32, but we have to definitely change our philosophy and make R-290 or maybe R-32 with EVI technology. I mean EVI, enhanced vapor injection, with injection directly to the compressor. This is interesting. The source of this graph is from the Copeland scroll, but this is interesting comparison. On these two graphs, we can see the comparison between 290 and R410. I know that R410 now is rather not so often used. Yeah, we are accustomed to R32. But look at the even lobe. In the standard compressor without vapor injection, we see that dropping down of the efficiency, dropping down of the efficiency below -10 is really big with the standard solution. But when we use R290, even on the standard compressor, we can achieve more than 60 degrees of the Celsius of the water supply when we have -24 outside. It means that this is really big difference when we are thinking about the using auxiliary electric heater. But at the other slide, I have to explain. And on the second graph, we can see the comparison even with the vapor injection, the compressor with EVI. The dropping down of the EVI compression is less, but still we can achieve more from the R290 refrigerant inside. This graph is from our academy, because in Poland we have a climate chamber, and before the providing goods on the market, all of our goods are testing in our chamber room. And we make the comparison between the standard monoblock R-52 and R-290. And we can see that capacity of the units at the start is almost the same, is very good. Even in -7, it's also very good. But look at the defrost time. How R-52 is dropping down at the, between +5 till -5. And how invisible is dropping down of the efficiency when we go across -5 and till 5 with R-290. It's almost invisible. One reason is that, of course, that is other refrigerant with the widest even lobe. But the second one is the algorithm of the defrost. On this graph, you can see the comparison with COP coefficient. And almost all of the temperature, we can see the big difference between 290 and R-32. It means that we can achieve even more than 2 if we have -25 outside, yeah? When we use, of course, the R-290 refrigerant. You know what is the bivalent point. All of us are the professionals, engineer, and we know that characteristic of the building and characteristic of the heat pump, when we match together on the cross of these two lines, we have a bivalent point. And bivalent point, when we use standard compressor, is, of course, depends on the climate zone. But in the Central Europe, we have between -2 till -10. I think this is the scope. But when we use R-290 and we go across with the characteristic of the building and characteristic of the heat pump, the bivalent point is -20, -22. Yeah? And in some places in Europe, I'm pretty sure that we should use the electric heater like an auxiliary heating source. Of course, I know that sometimes we have to do the service, sometimes it happens something with the units, and we have to auxiliary heater for the safe of the installation. But no, for the normal working. Where is the bivalent point? And electric heater is necessary? From my point of view, not necessary. But let's go to the dark side of this refrigerant. We know that dropping down with GWP, global warming potential, is strictly connected with the safety class. And GWP 3, it's very good because we are under all of this restriction, our governments. But safety class is A3. It means that it's extremely flammable. This is explosive, and we have to be afraid that if something happens. But today, in the kitchen, we have the flame and the gas we burn, and nobody afraid that something happens. Why are we afraid that something happens with our refrigerant, even if we have hermetic system inside? Yeah? Because this is monoblock that's standing alone on the outside. That nobody can happen that something is wrong. Of course, inside the unit, we make a special separation between the electronic part, electric part, and the refrigerant circuit. Yeah? This place, when we have the refrigerant, is almost freely going with the wind. It means that even if we have a leakage inside, it's not a problem because the mixture, oxygen and refrigerant, is a problem. But we have free space, and refrigerant can go outside of the unit. And this is last slide of my presentation. And I want to make some summarization of my speech. The first one is the temperature, water temperature. I'm sure that this refrigerant is the future for the thermal renovation, for this modernization and wave of modernization in Europe. Now, we have wave of the renovation, but we also have Repower EU program in the European Union government. And we know that if we can solve the lack of the installers, if we can solve the problem with the highest supply of the water temperature, we have to use this kind of unit, R-290, to be proper with the installation, to be sure that we can achieve, that we solve the demand of the energy inside, even if we have the smallest dimension of the piping and not suitable for the standard heat pump radiator with not enough area for the heating changings. Yeah? And also, we know that intelligent defrost is so necessary. You saw on the previous slide that dropping down of the efficiency and COP coefficients is almost invisible when we use R-290. And from my point, it's all. We are a Kaisai brand. We are standing here. If you have a question, I will be there. And from my side, thank you.